Hey y'all, today we're going to continue talking about the coordinate plane, and we're going to start talking about circles in the coordinate plane. So just like we can graph lines, we can actually graph circles in the coordinate plane. And we've worked with lines that are in the form y equals mx plus b. And some important parts of those lines, or that equation, is this letter m, which was the slope, and this letter B, which is the y-intercept. I'm sorry if those are too light, but this is just a quick chat about those. And so an equation of a circle also has some important things you need to know. The two most important characteristics of a circle are its center and its radius. The center, you might guess, is right in the middle of the circle. It is a point, and so it has coordinates. It has an x and a y. But we give them special letters, and those special letters are H, K. And so the x value of our center we call H, and the y value of our center we call K. The radius is the distance from the center of a circle, there's our center, to any point that's on the circle. That's our radius. And we use the letter R to represent our radius. And if we know both of those things, we can write the equation of a circle, which has this form. And so you can see that H and K are in there, R is in there, and of course we have an X and Y. In order to plot something in the XY coordinate plane, we always need an X and a Y. And so the first thing we want to be able to do is pull out the center and the radius if we're given the equation of a circle. So I have some equations of circles here, and it's in this form. You can see I have two sets of parentheses, both are squared, and then on the right side I have a number. And so we need to pull out the center and the radius. So I think it's always important to write down what those things are, and if you write them down every time, you will commit them to memory. And so I want you to notice that in this original equation, there is a minus sign in the equation. And then if you notice when I wrote H and K, there were no minus signs. So when I go find the center of the circle, I'm going to look at the sign in the parentheses, and I'm going to change it when I write my center. So, for example, H is going to be in here with X. Since that is a plus 5, when I put H in to my center, I'm going to make it minus 5. K is a Y value, so it's in here with my Y. Since it's a plus 4, I'm going to make that a minus 4. And so when I graph this circle, my center is going to be at negative 5, negative 4. Let me show you that. So I can use Desmos as a tool to check that I have the right answer. And you can see that when I graph the equation that we had, here's our circle. And then I plotted the coordinates of the center that I decided it was, and you can see it's right there in the middle. And so I have it correct. So you change the sign from the equation to write the coordinates of the circle. And so our radius should come from the right side of this equation. The right side of the equation in my original equation is r squared, the radius squared. So I need to square root the right side of my equation to get r. So I'm going to square root 4, and you can do that in your calculator, or if you know the square root of 4 is 2, you can find that the radius is 2. So we have the center and the radius. And now if I go back to my graph, I can see that my radius, starting from the center of this circle, to get to the actual circle, I have to go 2 units. It's always 2 units. So the distance from my center to the circle is always 2 units, and that means that my radius is 2. So I can do the same process for any equation of a circle that I get. I want to write the center for each of these, HK, and it's good to keep writing that, and my radius R. And so I'm going to get the coordinates from my center by looking in these parentheses and changing the sign. So I'm going to have -2 and +5. Oops. My radius R comes from the right side. My right side is my radius squared, and so I need to square root that side. The square root of 9 is 3. So my center is -2, 5, and my radius is 3. I apologize if this is getting too busy. Again, anytime I want to know the center or the radius, I'm going to write it. Constantly writing down what is the center, what is the radius, so I can eliminate some of my confusion. I'm looking in these parentheses, and I'm changing the signs. And I can put them in that order. 5, +5, +15. There's my center. My radius is going to come from square rooting the right side. Again, we're square rooting 9, and so our radius is 3. And so we can do the exact opposite. We can actually plug in the center and the radius to write the equation of a circle if we know what they are. I would always start by writing the equation of a circle. It's good to label to yourself that this first number is h and that number is k, and now we can just plug in x minus -14 squared plus y minus +11 squared, and then r squared, so I'm plugging r in. 1 is r, so it's 1 squared. And now I like to clean this up. We don't want to see minuses, and we want to end up without a squared on the right side. So minus is a plus. And so another way to think about this is when we were looking at the equation and we were trying to find out the center, we changed the sign that we saw. And so we can do the same thing. I'm starting with a minus. In my equation, there's a plus. Here I'm starting with a positive. In my equation is a minus. So it's the opposite. And then 1 squared is just 1. 1 times 1 is 1. And so there is my equation. So if I were to graph this on Desmos, and you could always use Desmos to check, it's a brilliant way to know that you're right, to give you confidence. You can graph this equation, and you should see this point, -1411, right in the middle. And you should see that it's 1 unit away, our radius, from the circle. And so I can do this for anytime I know the center and the radius. I would start by writing the equation. Remind myself that's HK and that's R, and then I can just plug the values in. And if I want to save myself a little time, I'm going to change the signs of my center. So I have a -13, so that's going to be +13. I have a +14, so that's going to be -14. And then I do my radius squared, square root of 5 squared. And if you don't know, whenever you square a square root, it cancels out and you're just left with a number, but let me show you that. I'm going to do the square root of 5. Oops. Square root 5. And then I'm going to square it, and you can see that that is 5. So the right side of my equation becomes just 5. So I'm going to go ahead and rewrite that. Of course, if we were asking you to write the equation of this circle and you left it like this, it would still be right. But we just traditionally see it this way, and so it's good to keep writing it the way that you might see it. Again, one more time, I'm always writing the equation. This is something we'll be given on a formula sheet, but things are faster when you know them. If you know where you put the water glasses in the kitchen cabinet and you go there every time, it's easier to get a glass of water. So I can just plug in my values. Again, I'm going to change the signs. I have a -5, so in my equation it's going to be +5. I have a negative 12, so in my equation it's going to be a plus 12. And then I plug in 3 for r. So it's r squared, so it's 3 squared. And then I can clean that up. Oops, not 15. 3 squared, if you don't know what that is, we can go into the calculator. 3 squared is 3 times 3, which is 9. Never be afraid to use Desmos if you need it. That's why we have it. It's a useful tool. So that's a couple ways we can deal with the equation of a circle. We're going to do a couple more in a future lesson, in our next lesson. If you have questions now is the time to get them answered before we go further with this. Make sure you stick around and answer the problems associated with this lesson. And while you're working, if you need help, there's 2 of us here. Please ask for it. Take your time on these, and good luck.